one of the things we can see with Moxy is that you use oxygen immediately when you start exercising, because we see it going, we see it going down. We see it, you start exercising, and as fast as the sensor can take a reading, we're seeing that number go down. And you're primarily using oxygen right from the beginning. So there was this notion that you were anaerobic for a while, until your other systems caught up, but that really isn't how it works.
Welcome to the Upside Strength Podcast, your number one resource for all things fitness and performance in Switzerland. Today, I'll be chatting with Roger Schmitz, who is the co-founder and CEO of Fortiori Design, the maker of Moxy Monitor. He's an expert in the technology of Near Infrared Spectroscopy and the inventor of the Moxy measurement algorithm. Roger, thanks for coming on the show.
Thanks for having me, Sean. I really appreciate it.
No, it's a pleasure. So for those who don't know what Moxy is, can you tell a little bit about who you are and what you do?
Yeah, so Moxy is a wearable sensor, and it measures oxygen levels in the muscles of athletes while they're performing their sport. It's typically worn over a large working muscle, and we're measuring kind of the balance of supply and demand for oxygen in the muscle, and we can use that as feedback to train more effectively.
Right. So for those who are maybe new to the technology and the whole concept, how is it different? How might it be different from a pulse oximeter that you put on your finger and that gives you the oxygen saturation, which is more on the artery side of things?
Yeah. So it's a great question to understand what's really going on here. So the pulse oximeter is measuring the same physics. So the fundamental physics is that hemoglobin and myoglobin change color depending on whether they're carrying oxygen or not. Mm-hmm. So that's the underlying physics that we're sensing. The pulse oximeter keys in on with every heartbeat, the arteries expand and contract due to that increase in pressure, and that's why they call it a pulse oximeter, because it's picking up on that pulse. And so that allows it to only measure the arterial hemoglobin. And no oxygen is consumed in the artery. So from the time it leaves the lungs all the way until it gets to the arterioles in the tip of your finger, it's the same oxygenation, because almost none is used on the path there. And so by keying in on that pulsation, it's isolating the signal to the arteries. And so that is just telling you that your lungs are doing a good job of oxygenating the blood they're getting, but it doesn't tell you anything about how much oxygen you're using. And so the pulse oximeter is a great tool. You see it in the hospitals because they want to know, are people breathing? Because if they stop breathing, they got to do something about it right now. Mm-hmm. And they use it a lot, like with the COVID patients. They're looking, are they struggling with breathing so much that they can't oxygenate the blood in there too? Then they know when they see that number get into the 80s, they have to do something. Mm-hmm. With the Moxy, the algorithm, it's the same fundamental physics, but the algorithm and the design of the optodes is such that it picks up on the blood in the capillaries. Mm-hmm. And that is where the action is. That's where the oxygen is being used. And so by measuring in the capillaries, it's a measure of the balance between supply and demand for oxygen in that muscle. And also the nature of the algorithm is such that it tends to exclude the big blood vessels. So we're measuring the pink parts of the tissue, not the deep red blood parts. We're going where the blood is really diffuse out in the capillaries, and that's where that signal is coming from. And that is really useful in exercise, because when your muscles are needing more oxygen than can be delivered, we can see that oxygenation go down, and it's a much more dynamic measure than what you see with the pulse oximeter.
Yeah, so maybe to backpedal just a little bit, you talked about color of hemoglobin, myoglobin. Can you talk a little bit more about that concept and what it actually means?
Yep. So both the hemoglobin and the myoglobin molecules. So the hemoglobin is what makes your red blood cells red. It's what gives blood that really deep, dark red color. And myoglobin it's a similar molecule, but it's stationary in the muscle, and it's what makes red meat red. So cows have a lot of myoglobin. That's why it's red meat, and pork has less, and chicken has even less. And that's why the shade of the meat is different, is because of the amount of myoglobin. Humans have a lot of myoglobin. We're good red meat. And when the hemoglobin is a carrier of oxygen, it's the main molecule that moves oxygen through the blood, and it gives the blood a huge amount of oxygen carrying capacity. So like, fish consume oxygen that's dissolved in the water. That's how they're getting their oxygen. But if you just look at water, you really can't dissolve much oxygen in the water. It just has very little oxygen carrying capacity.
Mm-hmm.
The hemoglobin, the blood there's some oxygen dissolved in the plasma, but it's about 4%. All the rest of the oxygen is carried on the hemoglobin. That's what gives it its massive oxygen carrying capacity. And when when it's carrying oxygen, it's a bright red color. And when it doesn't have oxygen, we tend to think of it as blue, but it's a deep dark red. It's almost kind of blackish.
Is that what we make the
red.
difference? Sorry to cut you off. Is that what we make the difference between the artery and the veins, the red and the blue? Is that to illustrate better the kind of the change in maybe the density of myoglobin within the blood?
It's not the density, it's how much of it is carrying oxygen.
Yeah, right. Sorry. So because
yep.
the hemoglobin is always there, but sometimes it's got oxygen, and in the artery is going to have a lot, and then
yep.
in the veins it is going to have less.
That's right. Yep. And that's why you'll see they draw the pictures of red and blue. Is the blue right. indicates deoxygenated, and red. The blue is just extreme. It doesn't really change to a totally blue color. But that color shift is precisely what we're picking up on. That's the tell that we get from physics to let us know the oxygenation state.
Yeah, so you talked about what we might read on a pulse oximeter, what percentage values we might see in terms of oxygen saturation within the arterial blood. And then can you talk about how that compares, what readings we might see on one of those and what readings we might see on a NIRS device? So like the Moxy, when you have it on the muscle, what kind of values might we see there compared to a pulse oximeter?
Yeah, so I don't think there's ever a case where the SMO2 could be higher than your SpO2, because there probably is some extreme case, but it'd have to be a dynamic situation. So generally the SMO2 is always lower than your SaO2. Your pulse oximeter is attempting to measure your arterial saturation, but then it can, because it's that balance of supply and demand, it can really be anywhere from 0 to 100. So if you do a really hard isometric contraction, like as hard as you can, you're essentially stopping the blood flow. The muscle tension is such, and especially if you're doing this at rest, your heart isn't pumping very much blood, and so by just tensing up that muscle, you can like create a tourniquet just with the muscle tension, and then you're using a lot of oxygen because you're creating all this force to produce that contraction. You can drive it really close to zero just doing an isometric contraction, and it'll go down in like 30 seconds. So right. you'll use the oxygen that's there, you'll use it all up in about 30 seconds. And so the whole time so when you do this, you like induce a tourniquet. So you've stopped blood flow, and you could do it we do this with an actual tourniquet too. You stop blood flow and you're using oxygen as fast as you can. The whole time it's going down, you're using oxygen that's stored in the muscle, because there's no more coming in, and we've stopped blood flow, so there's no movement of oxygen. And so for that 30 seconds, that kind of gives you an idea of how much oxygen is stored in that muscle. And the oxygen is stored both as hemoglobin in the capillaries, so the capillaries has some, and the myoglobin is just a store of oxygen in the muscle for just such an event. When you need 30 seconds of emergency oxygen, your muscles have it stored there on the myoglobin.
Yeah, so like you said, there's that really interesting interplay between kind of cardiac output and maybe if we talk about the pressure within the cardiac system, the circulatory system, and then the tension that we create at the muscle, and that interplay is going to dictate whether fresh blood can come into the muscle or out of the muscle or not, and that's going to give us a certain characteristics that are then going to make oxygen either available or not during exercise.
That's exactly right, and that's where that's what we see. Those concepts that you were just describing are super important when we're using this for strength training. So if you want to dial in the loads, the kind of the low level loads, it's often said 0 to 30% of maximum voluntary contraction. That's when you see a compression reaction. So the blood can still flow, but the muscle tension is such that maybe it squeezes a little bit of blood out of the muscle, but it can still flow. When you go like 30 to 70% of MVC, then we're seeing that reaction where we're restricting the blood flow out, but there's still some blood flow coming in. We're seeing the muscle pump up with blood. We call that a venous occlusion. And then the kind of the situation I was describing earlier, where you get to the tension is so high that there's no blood flow, then you get to that arterial occlusion, and that's when you don't last very long in that scenario.
We dove right into the Moxy here and those different concepts that I find fascinating that I wasn't even aware of even just a year ago. But can we take it way back? How did you first get to learn about the NIRS technology, and then what did you think of it at the time when you first encountered it?
Oh yeah, that's a great question. So I'm a mechanical engineer by training. So I started out my career, I was designing automated machinery that made disk drive parts. So I made robots that made parts, and then I got into we did a lot of laser processing because these are very small parts. So we'd do laser measurements on the parts, and we'd actually bend the metal with the laser. So it'd be we could warp the metal in a really controlled fashion with the lasers. Kind of so I got into optics. I learned that kind of on the job, and then the company I was at was developing a medical division, and they were looking at using near infrared spectroscopy to diagnose the severity of trauma in trauma patients.
Okay.
And so because I had some experience in optics, I moved into that group and I started designing devices, medical devices. And so that's how I learned the near infrared spectroscopy technology. And so I designed devices for them for about 8 years. I didn't invent that. The technology that they were using was already there, but I was able to learn their technology and make much more practical devices over the 8 years I was there. And then that business was failing for them. It turns out that they could just look at how much blood was around and know how severe the trauma was. They didn't necessarily need the near infrared spectroscopy, so that device didn't do well in the market for them. So then they ended up shutting down that division, and I got laid off. Well, then I came up with an idea for how to make the technology work without using expensive optics. So the whole time I was developing these devices in the medical space, we were using very expensive optics to control the light to make accurate measurements. And anything in optics is expensive. I mean, it's just, as soon as you get a lens involved, you get a piece of glass that you have to polish, and then you start talking about lasers and photomultiplier tubes, and those are the kind of components we were using. But then I came up with an idea for how to overcome the accuracy problem using LEDs as light sources with no lenses, no interference filters, no optics. So LEDs are a little bit of they're not the ideal light source for taking this measurement, but if you can accommodate some of those, less than perfect issues with the LEDs, then you can use them, and you can actually make a more accurate device. So what I was able to do was make a model that would predict exactly how the light traveled through the tissue, and so I would trace like one ray at a time, and I would know like the different wavelengths of light take different paths through the tissue because they scatter differently and they're absorbed differently. And like within an LED, an LED isn't a single color; it's a range of colors over about 20 nanometers. And I had to accommodate the fact that it's a nonlinear arrangement of that range. And so by making this excruciating, and it's a brutal math model, of how the light would go through the tissue, then I could use these LEDs and make a more accurate measurement than what we could do with expensive optics. And then, so that was that was kind of like, oh, that's cool, And then what I knew was medical devices. So I originally started looking for medical applications for the technology, and this was on my own. I was doing this, outside of the. This was after I worked for that company. And I was meeting with a cardiologist at the University of Minnesota here, and we were talking about using it with heart failure. And he says, this is cool. We could really use this. It'd be great technology, and it's cool that you've made it, so much smaller and more robust and more accurate and all that. He said, but you'll never get to market. He said, to make a medical device, you need millions of dollars in studies, and you have to submit to the FDA. He said, you should just make it for fitness. And then he says, then I'll buy it and I'll use it with my cardiology patients. And so that it doesn't need to be a medical device for this.
Right.
And so that's what we did. We pivoted. I had a partner by this time, and we pivoted, and we decided to make the technology work for fitness applications.
How did you come to that realization that you could do that without all the expensive lenses and lasers, and you can actually use the LEDs? Was that kind of a, spark of the moment kind of thing, or did that take you some time and some work to get to the conclusion that you could do it, and then develop the I guess the technology itself, and then the algorithm and everything that went with it?
That was something that occurred it was really over a long period of time that I always wanted to have a model of how the measurement worked that was, from the ground up, that was
Mhm.
a bottoms up kind of a model. The way everyone had approached NIRS up to that point was always through something much more empirical.
Mhm.
So they'd have some kind of hand wave at, well, this is kind of how the light goes through the tissue, and there'd be a whole bunch of approximations, and so you couldn't calculate it. But then what you'd do is you'd come up with some form of a mathematical equation, and then you'd somehow calibrate your system.
Mhm.
So a lot of times they would use a blood loop. They would pump blood through something that was like a tissue phantom that was supposed to mimic the human tissue, and then you would train your algorithm on this. But it was so hard. Nobody ever made a really good tissue phantom. They never. You'd
Right.
look at them and you're like, that doesn't look anything like an arm. It's some combination of plastic and tubes, and because it was just really difficult to make one that really looked like human tissue, and it never,
Mhm.
you couldn't. They didn't have fat. There was never sometimes they try and mix fat in, but no variable fat layer thickness or anything
Yeah.
like that. And so those were always limited in that you'd be training your algorithm to measure on something that wasn't a human, because there's really no way to measure SMO2 in a human without near infrared spectroscopy. So there's like no gold standard you could go back to.
Mhm.
They'd also do things like, well, they'd do animal studies where they'd isolate the blood flow in a limb, and it was all pretty contrived. And so I was always frustrated by that empirical nature of it. It's like, wow, there's so much guessing going on, and there's, the accuracy is always, you never quite know if you got it.
Mhm.
And so then my goal was always to make that bottoms up algorithm. Well, then the problem with that is the methods for doing it are so computationally intensive. So to make, like that ray tracing I was describing earlier it takes 4 days to do a run on a really high end computer
Mhm.
to
Wow.
trace enough of those rays
Yeah.
to accurately model what's going on. Well, you can't do that in real time, when you're
Mhm.
trying to take a measurement on a person. And so that
Yeah.
was the first trick, was to figure out how do you actually do that modeling
Mhm.
and actually come up with the 4-day algorithm. But that was pretty well known, that that wasn't really that inventive. But the aha moment was when I said, oh, I know how I can break this into steps. I could do the 4-day thing only one time, and then there's another element of it. That I could break off, and well, that takes a half hour of computation time, but I can do all of that ahead of time. I don't need to do that on every calculation. And then
Mhm.
there's only this little bit that I have to do every time we take a measurement. And so by breaking the algorithm into chunks, then I was able to do this really computationally intensive thing, but do almost all the work ahead of time and only save that last little bit for when we actually take the measurement.
Yeah. So
And
it's
that was the breakthrough that made that then made it work.
like you're front loading the algorithm almost, and embedding that into the technology itself, so that all that's left to resolve is the small part at the end of it, when the measurement is actually being taken.
That's right. Yep. So it's kind of like doing your homework ahead of time. Don't wait till the last minute to do your homework. Do your homework way in advance, and then only at the last second you just have to finish the last little bit, and then you get the right answer. So that's kind of the how that algorithm was developed, and that's what makes it. That's the trick that makes it work. That allows us to get that really good accuracy of the super computationally efficient or expensive process, but we can still get the accuracy in real time measurements.
Yeah, that makes sense. Who were the early adopters of the Moxy in the early days when you were still developing the unit? Who did you work with, and what kind of athletic population did you have a chance to work with in order to get that to where it is now?
So we were lucky in that we found Jurg Feldman pretty early on, and I think you've interviewed Andrew Feldman on here. That's Jurg's son.
I have.
Yeah, and so we, you know, my background is not in athletics at all. You know, I'm a mechanical engineer. I've got some training in in medical device design, but even in the medical space, I didn't have much. So when we started this, and when we said, okay, we're going to do this for athletes now, because the doctor at University of Minnesota thought that was a good idea. We just put up a website and we said, okay, we're going to make a thing. Who's interested? And we hired a marketing company to help with that. And they said, well, you can't talk about muscle oxygen on your website because nobody knows what that is. No one's searching for how to measure SMO2.
Yeah.
So we actually hired somebody to write blogs for us that were about things like heart rate and VO2 max and blood lactate, because that's the stuff people were searching for. And this was in the earlier days where search engine optimization was maybe a little easier.
Mm-hmm.
So we just put up a whole bunch of blogs that were about all of these related fitness topics, and then at the end we'd say something about, and this SMO2 thing is coming, and that was how Jörg Feldman ended up finding us, because he was searching the internet for blood lactate stuff, and he found some of our articles, and he says, that's all wrong on blood lactate, and well, we don't care, we just wanted to get your attention so we could talk about muscle oxygen anyway, and so then we started working with Jörg, and Jörg had he had been using the Portamon devices prior to this. So this would have been like 2011 or so. And I think he had 4 Portamons at that point. And they were a $15,000 device, but that was the cheapest device that was really available for athletes at that point in time. Mm-hmm. So then when we said, well, we're going to make a device for $1,000 or, right around $1,000, he was, that was great. Cause then some of these ideas he had developed for training with muscle oxygenation or with NIRS would now be much more, 15 times more practical,
right?
Relative to what he was doing with the Portamons. So we partnered with Jörg on that, and he was he ran our forum for quite a number of years, and so he just presented a lot of his ideas on the forums. It was a bit of a monologue, but then a number of people were were aware of Jörg, and people started, following his ideas. And of course, he was talking about actually muscle oxygen, and then we got kind of a following that way. So our earliest customers were people that were already aware of Jörg and some of the work he was doing with the Portamons, and then they just came over and starting using Moxy after that.
And what kind of sporting community were these people a part of? Was it more endurance athletes, more strength athletes?
At that point, I'd say it was much more endurance athletes, and I think that's just. I think Jörg had worked more in he's done a lot of sports, but he more endurance, and I think just in general, the endurance community is more used to this kind of analysis, this more kind of physiologic analysis. They do VO2 max tests and they do blood lactate, and Jörg had a long history with blood lactate, and so I think that was. That was a kind of what got us started in endurance. But then there was a variety too. We had people doing motocross very early on. We had quite a number of rowers early on too. So it was really just, and in hockey we had some hockey applications early too. So it was really just whoever would listen at that point, because it was kind of a new off the wall idea, and it was primarily who would be interested in this and who was willing to give it a go.
What are the current applications with the Moxy that you might not have expected right out of the gate? Some sports that you never thought might benefit from the technology that are now using it.
Just yesterday, I saw there was a study published on elite badminton players, and I didn't see that coming. It's a competitive sport and all, but in the U.S., it's kind of like croquet or something in the U.S. Badminton isn't something that's super competitive. It is in other parts of the world. It's a much more competitive sport, and so that was one that I thought, wow, I never thought anyone would use it for badminton, but they do, and this is like the second or third time I've seen badminton. That's been used in that. The diving is another one I didn't see coming. We've had people use it for they use it for training for free diving. They can't use it when they go super deep because the sensor's not built for that kind of pressure. But they can train their breathing for free diving, and that's another one that I didn't even think of as a sport really. But then that that was interesting. And then I think some of the military training, I'm surprised at the level of interest we have there, or not surprised, but it makes sense when you think about it. But it's one I didn't see coming up front, I guess.
So what are maybe some of the conclusions that have come out of those different lines of research within sports using the Moxy that maybe you didn't expect, or that people didn't expect in general, and that are slowly changing kind of the way that people see training in general when we talk about oxygen and performance?
I think the biggest shift, and kind of the one that, well, there's maybe two, I guess. There's two that are probably really high up there. So one is just the notion of lactate, and I think lactate was used for a long time because it was something that could be measured, and it was useful, and it was the best you could do, but then it kind of grew into an ends of its own. It wasn't a means for understanding how the muscles were processing oxygen. It became an end in itself, that the lactate was bad or something. And so Moxy has been, just rolling that back and saying, you measured lactate because you wanted to know the muscle oxygen, and now we can measure the muscle oxygen directly. Because there's still people that say, well, how does this correlate to lactate, or how do I use this to know the lactate? And it's like, why do you want to know the lactate if you can know the muscle oxygen directly? And so that's been one that I think has been a shift. And then probably the one that's more fundamental, and I'd say it's less, there's more of a, I don't know, shock value or something, or it's more controversial with the lactate. But what's less controversial or less apparent, or it's lower level, but I think even more important, is the change in the understanding of energy systems. Because one of the things we can see with Moxy is that you use oxygen immediately when you start exercising, because we see it going down. We see it, you start exercising, and as fast as the sensor can take a reading, we're seeing that number go down. And you're primarily using oxygen right from the beginning. So there was this notion that you were anaerobic for a while, until your other systems caught up, but that really isn't how it works. And so I think that changes a lot with how people think about different types of training. What do they call anaerobic versus aerobic? And that's something that, like I say, it's not as in your face as the lactate stuff is, but I think it's probably much more important. And people are really, some of the pro, I did a number of podcasts with some pro team sport trainers, working with NBA and NHL athletes. And that was one of the things that they brought up over and over again, was this, that they really had to rethink their energy systems analysis. Once they could see in real time what was happening with the Moxy, then they had to reconsider that. And I think that's pretty important in changing how people are going to train.
Yeah, that's really interesting. It's something I've been lucky to study for the last few months, mostly through Evan Picon, who's done a lot of work to kind of popularize that new idea or paradigm of energy systems. And it's true that at first it just throws you for a loop when all you've learned is, you've got the 3 energy systems, and those are the time domains, and this is how you train them, and that many intervals, that much, work to rest ratios, intensities, all of those things. But I think one of the main things that I took out of it is that just because the underlying physiology that we thought was true doesn't make sense anymore, doesn't mean that the methods that we use to train our athletes have to change completely, right? I think that's one conclusion that I went to at the beginning, and I literally thought everything I've learned for the last 6 years is just good to throw out, and I have to start back from scratch. Actually, no, the methods are what they are, and they do work for most athletes, and we can maybe get into the reasons for why there might be some differences in responses depending on who you're giving those to. But then it's just let's say the theory behind it, the physiology behind it. And again, it's all dependent on what we can measure at the time. But as far as we're concerned now, well, we don't have an anaerobic window. Like you said, oxygen is being used right from the onset of effort. And that does, throw a lot of people for a loop.
Yeah, and I think your point is really important too, that that just because that is different, and that's way different, it doesn't mean that your training is going to be way different. Because the training worked. People got stronger and faster and quicker and more powerful and all of that and healthier. That all occurred before Moxy existed. So it's not like, oh, you're doing everything wrong. It's much more in the refinement. You'll have, and a lot of the academic studies, they'll talk about non-responders. They'll say, well, we did this test, and on average everybody got better, but then there were some people that got just a little worse. Actually, they didn't respond to this treatment, and some other people got way better, but on average everybody got a little better. And it's always this, there's always this confounding, well, why is that? Why are there some why do some people not respond to beetroot juice and other people have dramatic, and that's when understanding the energy systems are important. When you kind of peel back that next layer and say, wait a minute, why did, it's not random why somebody responded and somebody didn't, or it's not, it is knowable, and there are ways of understanding it. And this is probably not going to tell you everything you need to know, but at least it'll give you more insight as to who, what types of people, or what people in what conditions. How can I predict who's going to respond from what types of training interventions?
Have you seen any studies or any work being done around testing somebody's limiters and then applying different training protocols and seeing if the responders and non-responders correlated to what energy, or to what systems, to what physiological systems were limiting that specific athlete?
I have not seen that. That's a much more difficult study to run than what is typically run. And I think, and just in general, I've made this comment to quite a number of people, just in general in the academic space, they tend to not use the data proactively. They tend to use. What do you mean by that? They meaning just what you said, where you would measure somebody, use the Moxy, measure something about somebody, identify their limiter, identify their ability to desaturate, their something, their recovery rates, identify some feature, and then say, okay, because of this, you should train using the A training method, and these other people should train using the B training method, and then see if that's better. That's the using the information to inform the training before you do it, as opposed to what tends to happen is, people will say, I've got two groups. I'm going to give one group beetroot juice and the other one not, and then I'll see if their oxygenation is different. And that's not proactive. You're seeing, well, what happened? You're not saying, oh, I'm going to measure their oxygenation first and decide you get beet juice and you don't, right, and then see if I can make everybody better instead of having non-responders. And that proactive use is a much more complicated study to make. But I think that's that's where the academics need to go to really uncover the value of the technology. Because if you're not using it proactively in training, then what's the point? If you're just saying, well, we trained for 6 months and now his oxygenation didn't get any better, well, that's a waste. We want to know, before you start training for 6 months, we want to know how to train so that they do get stronger. And that's where the value really is in that measure them on day one, and then change, structure a training plan based on what you learned in that day one measurement, so that they will for sure get better.
Yeah. Or even, I guess in the confines of a study, like you said, test them on day one, apply the same protocol to everybody, knowing that theoretically, if the hypothesis of the limiting systems is correct, we know that those will respond and those will not respond, or not as well, and then see if that actually pans out on the other side.
Yeah, that actually that's a great way to make the study less complicated. And then I think that's a great idea for making the study more practical to do in without having 1,000 athletes over a huge number of years.
Right.
Just keep it practical, and that's a great idea.
And do you think the resistance to doing such things is just that not enough people know about this new way of kind of measuring things and seeing how the body as a system of systems works with those different limiters, those different bottlenecks to output and performance? Maybe for those who are not familiar with the concept of physiological limiters, can you touch on that idea a little bit?
Yeah. So just so the concept is that when you go from, and I'll use it in, I'll use this in terms like of an endurance sport. So if you go from a load that you can sustain for a long time to a load that you can't sustain for a long time, and I realize that's all vague, I'll intentionally leave that vague. But when you make that transition, some system in your body was maxed out. Something happened. So you might use the term, your FTP in cycling or your critical pace in running or something like that, whatever that transition is. But the idea is that some system was pegged first, and was it your cardiac system, was it your respiratory system, or was it your muscles' ability to use oxygen? Which system got maxed out first? And with the Moxy, the first thing we try and do is divide that between supply limitation and utilization limitation. So basically, and this is a little bit oversimplistic, but the utilization limitation means that your muscles can't use all the oxygen that you're capable of delivering. So when you're going all out, you're going as hard as you can go, there's still oxygen left. So we would see, 40% on the Moxy, and we'd say, well, you're not using all there's 40% of the oxygen left. So if you want to go faster, your muscles, and it's going to vary depending on what sport you're doing, but if you wanted to do whatever that was, whatever sport you were doing, if you want to do that faster, you're going to need to use more oxygen. And the flip side is if you're doing this, you're going as hard as you can go, and we're seeing low oxygenation values. So we know while you're, like 10% or 20%, we know we're using almost all the oxygen that you can get there. Then if you want to go faster, you need to be able to deliver more. Well, then with the Moxy, we can further discern, are you limited more by your cardiac output? Are you limited by the ability to pump blood, or are you limited by your respiratory system, which is often the ability to remove the carbon dioxide? And for that determination, we'll look at a lower priority muscle. So like for a cyclist, we might measure on their exterior deltoid. Now that you're doing work with your exterior deltoids to maintain your balance and a little bit of stability control, but it's not turning the crank on the bike. The legs are doing the majority of the work. And if we see the exterior deltoids desaturate dramatically at those high loads, that's an indication that the body's run out of cardiac output and it's redirecting blood flow from the arms, from the arms to the legs. And to do that, you have one pump, and the only way for it to redirect flow is to restrict someplace and open up someplace else. And by restricting the arms desaturate, but that moves more blood flow to the legs, and that's a way of dealing with limited cardiac output, and it's a great way of dealing with. The flip side is if you're hunched over and you're not, because you're on the bike and you're not breathing, not moving enough air, the carbon dioxide will build up in the blood because you're not getting rid of all the CO2. Well, that's a vasodilator, and that would actually prevent the arms from constricting. And so you'd be going all out. We'd see low oxygenation in the legs, but your arms are still up at 90%. And then we'd say, okay, well, if you want to go faster, you got to move more air to be able to get that CO2 under control. And that's overly simplistic, but it kind of gives you a kind of a framework of those three types of limiters. And there's other ways you can be limited. You can be limited by muscular coordination. If you just have, if you don't, just not experienced in that sport, you have crappy pedaling techniques, so you're only using one muscle to do all of the work of pedaling. You're not using all your muscles to lift on the pedals and all of that. That can also be a limiter. And people have looked at using that. They want to see that all of your muscles are desaturating on the legs. And so you can use Moxy to help identify that kind of a limitation as well.
Yeah, it's really, that concept is really interesting about the physiological limiters. It's that essentially that oxygen loop, right? Oxygen into the body through the respiratory system, through the lungs, goes into the blood, gets pumped through the system, arrives at the muscle, gets used or not, depending on how good you are at using it, and also depending on the intensity of the activity itself, because that varies. Obviously, the higher the intensity of the activity, the more O2 you're going to be using, and then getting the CO2 out of the system again through the circulatory system, through the respiratory system, and then breathing that out. So it's really that loop of oxygen, which is really interesting because it puts oxygen really at the center of performance, whether you're talking about something on the endurance side or even on the strength side of things. Obviously there's more of a kind of a neurological factor on that side of things when we talk about muscle contraction, when we talk about coordination of contractions when we talk about recruitment patterns and stuff like that. But we still have that component of you need O2 around if you want to contract your muscles. If there's no O2, you will not be able to contract any farther, or at least not for very long at all, right?
Not for very long, right? Yeah. I think that's a great insight. I think that it does. It just gives you. It allows you to, by being able to measure it in real time in place, you're able to just get a vision of, or try and get a glimpse of that system and say, well, how are all of those systems working together to produce energy? I think that's a really important concept. And it's true that it's for endurance sports, but a lot of these non-endurance sports are still, oxygen is still extremely important. And if you can use your oxygen better, you can do the sport better most of the time.
Yeah, that's a very important statement, like you said. So if we talk about, the Moxy Monitor in 2020 and what maybe you had envisioned for it at the beginning, where does it stand now in terms of the technology, the development of it? What are its strengths? What are its weaknesses, if you still see some? And where would you like to see the technology move forward in the future?
Okay, so I think there's a number of concepts there. So one, I'm really pleased at this point with how well the measurement has performed, because we've measured thousands and thousands of athletes, and I can't say, I mean, we've had some head scratchers where, there've been some outliers here and there, and not that we've never had any issues, but by and large, I'm very pleased with that. The measurement has been robust. It makes sense. It works. We've had validation studies and things like that have shown that it's measuring what we say it's measuring. And so the algorithm, the hardware that does the measurement, I think is really robust. It's really getting well accepted, and so I'm super happy with that area. I'm pleased with that aspect of things. And then I think the reliability of the devices. They're tough. They're durable. They're not finicky for the most part.
You said they go. Sorry to cut you off. You said they go underwater. How deep can you go with one of those?
We test them to 3 meters.
Okay. So in a pool is fine, but don't.
In a pool is fine, yeah. But if you're doing the free diving, if you're doing the free diving at 80 meters or whatever the crazy stuff they do, then no, then we'll have to think of something else. Yeah. We'll have to build a metal case or something that could withstand the pressure. But then I think looking forward. When we started this was a self-funded startup, and so we couldn't do everything we wanted to do because we didn't have the money to do everything we wanted to do. So we decided focused on the sensor. Make the sensor, because no one else can make a sensor like that. So make the best sensor we possibly can, and then the corner we cut, or whatever and I don't want to say it quite that negatively, but the ability to get this out there was, well, we just decided we're going to interface with other devices for displaying the data. So when we launched the product, the only thing we interfaced with was the peripedal software. And it was great. And we still use peripedal. It's still really commonly used. It's a really nice tool for showing the data in a simple way, and it works great. But then, over the years, a lot of other applications have added connectivity with the Moxy. The VO2 Master, the Panoe, the Cosmed, the Garmin's. We can interface with Garmin's and the Wahoos, and the head units and all of that. But all of that is still third party. It's still not us making that application. So that's one of the things I'd like to see, is us having maybe a little more control over that user experience, or having a little bit more Moxy, have that user experience implement some of these concepts for training in a more more direct way, just more focused on, like the ability to determine a limiter, and the ability to guide interval training, and the ability to guide a recovery. Have all of those things be more integrated into the user experience of the data display application. And there's a lot of things going on in that area. IDAG, our partner in Europe, is they're making a software. It's out now, I think. I've used that for a while, and it's nice. They're starting to incorporate those features into that software. So that's what I want to see more of, is just improving the user experience to make use of these new insights that the Moxy brings in a more refined way. You can do all these things now. It's just not, it's just not as refined as I'd like it to be. It's kind of like, Apple. I want it to be more like an Apple device where you get down to one button and it still does everything you want it to do.
Yeah. Is that something that so you said IDEAG is working on such a software. Is that something that you're looking to have in an app format as well for, iOS, Android? Because I know when I first got the Moxy, I was looking for an easy way to display it when I was in the gym. And on the computer, it was the Peripedal. I have a Mac, so I had to install parallel desktop and then run it on there. And it wasn't always the best way. But like you said, there's other third-party applications that allow you to grab the signal from the Moxy. So I'm using the View2. The View2 Master Manager app on iOS on my phone.
Yes.
And so I'm able to catch the SMO2, the THB, all that in real time on the phone, which is really practical because now, I could be doing a bike session or whether it's me or one of my athletes, and I can have that visual right on there.
Yeah, that's there's nothing like immediately pending on that, so I don't want to get people's hopes up too much, but it's definitely on the radar screen of things that the iOS, the gap in iOS support is huge. The VO2 Master app is the one that really covers that, but then it's not their primary focus. And Peter does a great job. I mean, he's done wonderful with incorporating this, and he's got a great product himself. The VO2 Master and the app he's developed is really awesome. Mm-hmm. The limitation there is that the Moxy isn't his primary product, so he's put this in there, and it's wonderful. But that's where I think having us developing some more, and it might be just us working more closely with Peter to implement some of these things, and there's things like that going on right now as well. That's how that came to be in the first place, was just having a conversation with Peter, and he said, "Oh, I can add that into my app here quick." And so those are things that I think we'll continue to see more of, more integrations into other applications, and more availability of using it on a wider range of platforms.
Yeah, so you talked about that accessibility and that ease of use, and the idea of auto-regulating training using a tool like a Moxy. So again, for those who are not familiar with this idea, through measuring SMO2 in real time, we can then, depending on what the goal of our session is, actually auto-regulate it using that technology instead of, for example, giving an arbitrary number of intervals to perform. We could say, well, let's set some parameters in terms of how far do I want to desaturate, how far up do I want my recovery to be, and then how many intervals can I do, or I'll keep doing my interval work until I can't reach those metrics anymore, which is a lot more interesting than just saying, oh, well, just do 10 intervals, or just do 5, or just do 20.
Yeah, but I think that's a really, like you say, fun, or I think that'll help motivate people, because it can give them feedback, while they're actually doing the work. Am I doing the work to accomplish the result I want? And Evan has really done a great job of helping people understand how you can use it in that way. Depending on what your goal is, he has that webinar on hypertrophy training that's really good. Even if you're not interested in hypertrophy training, his hypertrophy webinar is really nice, because you can get a really good idea of how the technology can be used to target a specific outcome. And so he says, well, these are the things that, he does a great job of looking through the literature and saying, these are all the types, these are the factors that cause hypertrophy, or that, cause your body to grow more muscle. And then this is how we can know if you're doing those things or not. Here's how we can use the Moxy to see if you're actually doing those things, or if you're doing something else. And one of the points he brings up is for some people, it's really easy. Many of the movements they do put them in the zone of making more muscle, of hypertrophy. And other people, there's a very narrow window. Some people they complain, oh, I can never put on muscle mass. Well, they're probably in that. There's only a very few things they can do that put them in the modes where their bodies are able to add muscle. So being able to see that and adapt in real time, I think could be really motivational and effective, actually produce results.
Yeah, like you said, I think the gamification of training is something that is really interesting to me. And somebody else, I don't know if you're familiar with Pat Davidson, who recently developed with what's the name of the company? I forget. They make gym equipment, and they're able to rig on all the different, the presses, the leg presses, and the chest presses, and all those machines, actually able to rig a monitor that gives you in real time, how many watts you're producing, distance travel, force, all those things. So you get a score essentially right as you're doing the training, which, like you said, gives you some direct feedback, quantifies your effort directly for you beyond just this is how much is on the bar, or this is how many watts you're pushing on the bike. And that might give that extra little bit of, like you said, incentive to people and to athletes to actually push to where they want to be and actually get the results that they want out of their training.
Yeah, and I think that's when you can combine that gamification and put that on top of something that has, actual physiologic benefits. I think that's a really powerful combination.
Mm-hmm.
When you can say, this is why this is going to make you improve, and now I can see that you're actually in that zone, or you're actually getting to that goal. I think that's a really powerful mix there. So I think that'd be great to see some of those things continue to develop as well.
Is there any sports or any fields that you can think of that haven't really used the Moxy yet, but that could greatly benefit from it, and you'd like to see more work being done in those sports?
I'd say not. We've really covered just a huge range of sports. So I don't think there's any sport no sport that I know of. I'm sure there's more sports than I know of, but no sport that I know of. But what the area I'd really like to see us continue to develop in is in physical therapy, and we've really seen some interesting traction there in the last year or two. And we just did a couple of podcasts on physical therapy, and I think there's some really important opportunities there, because it's the same concept of limiters, and it's just that everything's messed up because of the injury, and you still have to understand, where are you at? What's limiting me now? Because it's going to be way different than what it was before the injury, and how do you rehab that injury as effectively as you can without doing more damage, and so I think just the acute nature of the issue, and the fact that you've got a physical therapist that is capable of understanding this data and making use of it, I think makes that a really interesting opportunity. And so I think we're going to see more and more applications in physical therapy.
So when you're talking about this, maybe to give an example, and correct me if I'm wrong, but let's say you've injured your left leg, say maybe your left knee, and then you go into rehab, and if you put a Moxy on the left quad and on the right quad, you might not see the same values when it comes to oxygen utilization, even though we're doing the same exercise on both legs. And so through that process, we might be able to optimize the recovery process to get that left leg working again as well as the right. And I guess there's many factors going into this. There's got to be a neural component to the kind of sub-recruiting the muscles around the injury to prevent further injury. So maybe can you talk, maybe not in great depth, but in just overview of that concept of using Moxy in physical therapy?
Yeah, so I think one of the just a couple of examples, I guess. One is Aaron Davis talks a lot about using it with force plates. So he has dual force plates, and he has people do squat jumps with a Moxy on each leg. And so the one of the goals of therapy is you want them to be doing the squat jumps with equal force, so their force profiles are the same on both legs. But then more from a physiologic perspective, you also want their SMO2 profiles to be the same on both legs. And so that can get you some information on, are they using the correct muscles? Because you can use several different muscles for doing a squat jump. It doesn't just have to be the VL. And depending on where the injury is, are you compensating with other muscles? And so maybe you can get the same force, but you're doing it using muscles that are different between your left and right leg, and you could pick that up with the Moxy then. And then you'd know, okay, maybe this muscle is atrophied, or maybe its neurologic response is muted because of the injury. And even though the injury's healed, those things haven't recovered yet. And so then they could do the therapy to get around those issues. Another one in our 2020 Moxy Summit, Yuri Dosto gave a presentation on iliac artery syndrome, where he had cyclists measuring on the left and right leg, and he had left-right power meters, so he knew that they were doing 50-50 power, and they saw that the left leg had much lower saturation than the right. I believe it was the left that was lower, and that was correlated to the iliac artery syndrome, so there was less blood flow to that leg. And that's just another example of you being able to see that this athlete had pain. Don't know why they have pain. You can run a fairly simple test and get some pretty incredible information. And then they went and had the iliac artery surgery. They come back, and then now they're the same. So then you can see the problem's fixed. So that's another, by being able to. What was really important about that situation is that they could be tested under load. That's something that you don't typically think of in a hospital. You go in and you get a CT scan or an MRI or whatever. You're just laying there. Right. But what this was a dynamic test, they could actually have them cycling like they do in the wild, and get this data, because that's when they would only have the problem at their highest powers. They would only have the leg pain at the high end. And so that's another way of being able to pick this apart. And that's where the physical therapist, I think, is probably, or the athletic trainer, the athletic trainer, the physical therapist, they're the ones that have the skills and have the athlete in a place where they can do their sport and be able to use this information really effectively.
In your mind, what's missing currently for the Moxy to be kind of more widely accepted, more widely known as a very, very practical and very useful technology in the field of both performance and rehab, like you just mentioned?
So in the rehab space, I think it's just time, and it has to kind of spread organically a little bit, and just people to have to see it more. In the performance space, it's been used a lot longer there, and I think what we're seeing is, the people that get used to it and take the time to get over the learning curve do really well with it. What I think is missing is some of the refinement and simplification that's needed to make it more useful as just a consumer product. Because right now it's maybe intimidating, because we're giving you the raw data. We're not doing any refinement on the data in the app, and that and to be honest, that's intentional. We didn't want to overstate. A lot of people have told me, "Oh, just make a red light, green light thing to tell people when to start and stop." But it's like, well, but I'm not sure I always know when to make it red and green. It's complicated. The human body is really complicated, and I want a smart trainer that knows what they're doing to be able to say when to start and stop. And I didn't want to take that away, or I didn't want to be overconfident in when to turn the light red and when to turn it green. Yeah. And but I think as this matures and as the trainers work with these thousands of athletes, and I think the data will start to come out that will know when, at least under what range of conditions we can do. We can tell you when to start and stop your intervals. We can tell you, like you were talking earlier about your reps and sets, that we can make that more automated and be confident that we're not just making up numbers. We're not just saying, this will work for everybody. We can come up with something that is truly benefiting the people we want to help.
Yeah, you can maybe even have more input maybe from the coach himself in terms of setting those parameters and saying, I want the light to go green after you're above 80% SMO2 and or below 120 heart rate and or after 2-minute rest, and then I want the light to go red below maybe 15%, and then I want those criteria to stop the session and give a little bit more. Like you said, I think it is good that you do give the raw data and that you don't just kind of water it down all the way to green light and red light, because the insights from the data itself are really interesting just from a practical standpoint when you're getting to learn the technology and how it works. But yeah, maybe there's that in between somewhere where you can still give the raw data but at the same time, let the people set their own parameters when it comes to organizing their training, just like they might do, they might do on a bike today, where they have an app and they can just set, I want 2 minutes at 300 watts, and then I want 1 minute at 50 watts, and I want 10 intervals and those kinds of things.
Yeah, and I think that's where it's headed. So I think we'll see, I think it makes sense for this to be a product that is, first developed at the high performance end, and then I think we'll just see it expand into people that are less likely to be in the Olympics, and then expand to the people that are the podium on their on their local race or whatever, and then people that are just trying to improve their times or improve their personal bests. So I think we'll see it move in that direction as more and more of these trainers and coaches develop that understanding like you're talking about.
Roger, it's been a great pleasure talking with you today, and learning more about the inception of the Moxy and the history behind it and all the great things that are done in that field. So for the people that are still kind of a little bit on the fence about, okay, is that useful? Is there any practical application to that tool? What's your 60-second pitch to people that are still not fully convinced that there's actually something there in terms of the benefits in regards to training?
So I think at the high performance end, that we've got so many examples of people that have used it very successfully, and so yeah, there's absolutely something there. It is the learning how to use it is so much more accessible than what it was even just 2 years ago. So the Moxy Academy, the Muscle Oxygen Physiology course, the Training Integration Guide course, those are both available for free right now, and the Evan Picon's course on I forget what he called, the strength, the science of improving performance with NIRS, something like that. I forget the exact name of the course, but that's available for sale. That is a very accessible, practical course for someone that's willing to take the time to watch a few hours of videos. You can become very proficient with the technology. It's not like in 20 minutes after opening the box you're proficient. You do have to put in that time, but if you do, the rewards are there. Many people have done that and have really learned to train more effectively. So even though it's not quite to red light, green light yet, we're moving in that direction. But it's the richness, the richness of the data and the value of the data is way more accessible than it was even just a couple of years ago with those courses. And so I'd encourage people to take the plunge and dive in. And a lot of that you can dive in without you can jump into those courses before you buy the Moxy. So.
Yeah, like you said, there's a lot of even Evan's done some webinars, Aaron Davis as well, and many other coaches and practitioners that are using the Moxy and have been for years now. You can find a lot of great presentations on the Moxy Monitor YouTube channel as well. So I encourage anybody who's interested in learning more to go and check those out. Roger, I'm gonna list all of those in the podcast description so people can easily make their way to the different places. Where can we find out more about you, Roger, the man at the forefront of this adventure, if they want to kind of follow the day-to-day process, or maybe not day-to-day, but week-to-week, month-to-month progress on all the different projects you're working on?
If you go on our website, there is we have a newsletter sign-up form, and then you'll be on our email list. We send out a newsletter. It's a little bit sporadic. Sometimes it's 2 a month. Sometimes it's 1 a month. Sometimes we go 6 or 8 weeks. But the newsletter is where all the action is. So when there's new software, when there's new education courses, when this COVID's over, people will go back to doing in-person courses again, I'm sure. And as those come up, we announce those in the newsletter. And then of course, social media. We're on Facebook and Twitter.
Awesome. Thanks so much for your time today, Roger. It was a pleasure talking to you.
Yeah, it was great chatting with you. Thanks so much for pulling this all together.
All right. Take care.
Take care.